So this was a numerical, a simple Rankine cycle was between the pressures 28 bar and 0.06 bar. The initial condition of steam being dry saturated. Calculate the cycle efficiency, work ratio, specific steam consumption. Okay, so pay attention. So 28 bar is pressure of which component? 28 bar pressure कशाचा आहे? Huh? Turbine. Which component? One answer I got, turbine. 28 bar is the pressure of which component? So we are at the end of the chapter. 28 bar is the pressure of which component in the power cycle? How many components are there? How many components are there? So does anybody remember? Right. So we have this saturation curve. Then there is this Rankine cycle curve we have. Right. 1 to 2. Sorry. 1 to 2 to 3 to 4. Right. So in this case, 1 to 2 is what? Pump, feed water pump. 2 to 3 is what? Boiler. 3 to 4 is what? Turbine, isentropic expansion, right? 4 to 1 is a condenser. So 28 bar is the pressure of boiler, higher pressure, and 0.06 is the pressure of condenser. Okay, please remember this. And condition of steam is dry saturated, that is at the inlet of turbine. So this will not be the figure in this case. So figure will be somewhat different. So I will again draw the TS diagram. Temperature versus what is S? What is S? S is enthalpy. S is entropy. H is enthalpy. Okay. So in this case, they have given you the condition of steam is dry saturated. That means it will lie on vapor saturation curve. Then the expansion will take place in the turbine. Then condensation in condenser. Then again pump will pump. Then we have to send it to boiler. Boiler will convert water into steam. Here 1 to 2 to 3 to 4. Okay. What is the pressure here? 28 bar. What is the pressure here? 0.06 bar. Okay. This is the correct diagram. Or any correction is there? So they have given you steam is being dry saturated. Okay. So here at the inlet of turbine, the steam is dry saturated. That means dryness fraction is how much? If the steam is dry saturated means dryness fraction less than 1%. Dry saturated means dryness fraction is 1. When we say liquid saturated, here X is 0. When we say dry saturated, here X is 1. In between them, if I say wet steam, then it will be between 0 to 1. So now let us start. They asked you cycle efficiency. What is the formula for cycle efficiency? W net divided by Q in. What is the formula for W net? Turbine work minus pump work. What is the formula for turbine work? H1 minus. Array, look at the diagram. Don't copy from book. Yes, H3, that is enthalpy at inlet of turbine minus enthalpy at outlet of turbine. So in book might be the notation will be different, but please refer to the diagram. Then what is the pump pressure? Specific volume at point number 1 into P2 minus P1, right? Okay, what is remaining here? Q in. What will the Q in? The heat supplied in boiler will be H3 minus H2. Is it correct? So enthalpy at outlet of boiler minus enthalpy at inlet of boiler, H3 minus H2. Now see here, H3 we can calculate easily because it is lying on the saturation curve on steam table. We can directly calculate. Then H2 we can calculate. How to calculate H2? H2 will be equal to H1 plus pump work plus pump work. Correct? Then H4. So the crucial criteria here is to calculate H4. We don't know the dryness fraction at point number 4. That is a crucial criteria. So one by one we'll calculate all the properties. So let us start with turbine work. Work done by turbine. So here WT is equal to H3 minus H4. H3 will be what? H3 is nothing but at 28 bar, it is nothing but Hg3. So at 28 bar, go to the steam table and check the Hg value. Where is your steam table? If you don't have, then look in the app. In app also you can check. 2802. That's it. Kilojoule per kg. It is as simple as it is. Now next is calculation of H4. How to calculate H4? Now see where the 0.4 lies. 0.4 कुठे lie होतोय या diagram मध्ये? This diagram. 0.4 lies in the which region? Wet region. It lies inside the saturation curve. That means it lies in the wet region. So what is the formula for H4? It will be equal to HF4 plus X into HFG4. Correct? Now, what will be the HF4 at how much bar? 0.06 bar. So go to the steam table, go for 0.06 bar pressure and check its HF value. How much is it?
1.
No. HF value. Go to pressure table. 151. 151.6. Okay. So what is the HFG value at the 0.06 bar? 19 kilojoule per kg. 1 है ना? 0.9 है क्या फक्त? So 2415.9. So see here we know HF4, HFG4, but we don't know dryness fraction. How to calculate dryness fraction? So dryness fraction. Okay. How to calculate dryness fraction? Here we have to make use of another property. 3 to 4 is what process? 3 to 4 is isentropic process. That means entropy remains constant. So whatever entropy at point number 3 will be equal to entropy at point number 4. Correct? What is the entropy at point number 3? So S3 is nothing but at 28 bar. You have to search for SG value. So go to 28 bar pressure, search for its SG value. Why I have taken SG? As everybody understood. So see here 0.3 lies on vapor curve. Okay. So this left side is what? This is liquid saturation curve. Right side is what? Vapor saturation curve. Any point lying on the vapor saturation curve, here we have to go for SG, HG, etc. Any point lying on liquid saturation curve, Here we have to go for SF, HF, etc. Okay. What is the value here? 211. Okay. What is the unit? Kilojoule per kg Kelvin. So that will be S4. Now, entropy at point number 4. What it will be? Point number 4 lies in the wet region. So formula for S4 will be SF4 plus X into SFG4. Okay. So this is a formula for entropy in wet region. Now, what is the SF4? SF4 is nothing but at 0.06 bar. Check the value at 0.06 bar. What is the SF value? Go to the pressure table. Go to the steam table. Go to 0.06 bar. Go to SF table. SF column. 0. Kilojoule per kg Kelvin. And what is the SFG value at 0.06 bar? 8 plus kilojoule per kg Kelvin. Now I will put all the values. What is the value of S4 is equal to S3, that is 6.211 will be equal to SF is 0.521 plus X into 7.8. So from this calculate X value. Calculate X value. Calculate X value. So those are in online mode. Calculate. Yes, Pranali Gaikwad 0.72. Correct? 0.72. That is rightest fraction. What is the meaning of this? 72% is steam and 28% is water. 72%. Now, why we calculate dryness fraction? Because we wanted to calculate H4 value. Now, I will write this H4 equation once again. So again, H4 is equal to what? Is equal to HF4 plus X into HFG4. So here HF4 is how much? 151.6 plus X we have just calculated 0.72. What is HFG4? 2415.9. 2415.9. So calculate H4 value. One five 18. 0.02. Others also correct. 0.04, okay? 0.04. What the 4? 19. 27. अरे एवढा काय फरक पडणार आहे का 20 चा फरक पडला फक्त. Please do this calculation. Don't do your calculation. Do this calculation. मग ते जाऊ सोडा. 1891.04. ठीक आहे. So why we calculated H4? Because we wanted to calculate turbine work. Now let us calculate turbine work. WT will be equal to H3 minus H4. What is H3 we calculated? 2802 minus 1891.04. Calculate turbine work. Calculate turbine work. One 46. 4693. अरे एवढं कसं असेल? काय केलं? प्लस केला का तुम्ही? 901. 910.96 kilojoule per kg. Now next, what we have to calculate? Turbine work we calculate. Next, calculate pump work. Okay. Now how to calculate pump work? Pump work is specific volume at point number 1, P2 minus T1. So specific volume at point number 1. Where is point number 1? Point number 1 lies on liquid saturation curve. So that is why point V1 will be at 0.06 bar. V1 will be VF1. So go to the 0.06 bar pressure and search for VF value.
0.006.
Others, boys, check. Is it correct? What is the unit? Meter cube per kg. Now calculate pump work. 0.001006 into 28 minus 0.06. Calculate this pump work. 2.81 kilojoule per kg, right? Is it correct? Okay. Why we calculate pump work and turbine work? Because we wanted to calculate net work. Net work is turbine work minus pump work. So I'll write down this. Turbine work is 910.96 minus 2.81. So I think it will be very simple. 908.15 kilojoule per kg. Okay? Kilojoule per kg. So this is a net work done. Now next is to calculate Q in value. In order to calculate efficiency, we have to calculate Q in value. What is the Q in value? H3 minus H2. Here calculate H2. H2 is H1 plus pump work, right? H2 is H1 plus pump work. That means here, see here, it's the 0.2. 0.2 is whatever enthalpy at point number 1 plus this much pump work. Whatever pump work we have, that we have to add in H1. So H1 is nothing but what? At 0.06 bar, it is nothing but HF value. I think we have already calculated, that is H4 151.6 kilojoule per kg. And now H2 will be equal to pump work is how much? 2.81. So 151.6 plus 2.81. 2.81. This will be 1, 4, 3, 4. 154. 150 kilojoule per kg, right? So calculate Q in. H3 is how much? 2802 minus 154.41. Calculate this one. This will be what? 9, 5, 5, 4, 2, huh? Oh, sorry. It is 151. 20. Huh. 20. 59 kilojoule per kg. Now calculate thermal efficiency. Thermal efficiency is what? W net divided by Q in. W net we calculated 908.15. Q in we calculated 2647.59. To calculate this, somebody has calculated. Asauri Chavan has calculated 0.343. Others in online, please calculate. We can say this is efficiency 34.3%. So where you have made mistake? Right, 0.6 घेतला असतं तरी पण मी समजलं असतं. How you mistaken 6 for 4? Okay, next work ratio. So this might be new, but it is very simple term. Work ratio is actually a ratio of W net divided by turbine work. So here W net is how much? 908.50 divided by turbine work. How much we calculated? 910.96, right? So calculate work ratio. Others 0.99. 7, correct. And last is specific steam consumption. Specific steam consumption. It is nothing but ratio of 3600 divided by W net. So 3600 divided by W net is 908.15. Calculate 3.964. We check its unit. I'm not sure about its unit. Kilojoule. Let's take in this how much. Kilogram per kilowatt hour. Sorry. So unit here for steam consumption is kilogram per kilowatt hour. Please write down the unit. Unit for specific steam consumption, kilogram per kilowatt hour. And there is no unit for work ratio because in numerator we have kilojoule per kg, in denominator we have kilojoule per kg. Both will get cancelled. There is no unit for work ratio. Okay. And last one here. Okay. Okay, So numerical part is over. I think I have taken sufficient numericals. In assignment also I will provide more numericals, you can solve it. So you might have gained some confidence, I hope. तुम्हाला उद्या प्लांट मध्ये पाठवलं तिथल्या तुम्हाला इंजिनियरने सांगितलं की बॉयलर प्रेशर एवढा आहे, कंडेन्सर प्रेशर एवढा आहे आणि स्टीमची कंडिशन टर्बाइनच्या आधी अशी आहे, सुपरहीटेड स्टीम ॲट 600 डिग्री सेल्सिअस. आय होप यू विल बी एबल टू कॅल्क्युलेट द सायकल इफिशियन्सी. तेवढं तुमच्याकडनं एक्सपेक्टेड आहे आणि ते तेवढं तर तुम्हाला यावं की किती सायकल इफिशियन्सी येऊ शकते, राईट. So don't just think that it is limited to your syllabus also. Syllabus only. You might apply this knowledge if you become really plant engineers in some thermal power plant or hydropower. Thermal power plant mostly, because in hydropower plant we don't go for steam. Hydropower plant मध्ये काय असते, डायरेक्टली पोटेन्शियल एनर्जी असते डॅम मधले, ते आपण पाणी परत त्याची कन्वर्ट करतो कायनेटिक एनर्जी मध्ये. That kinetic energy we again convert into electric energy. हायड्रोपॉवर म्हणजे जे कोयना असे जे डॅम आहे, ते डॅम मधलं परत पाणी खाली सोडून केलं, त्यामध्ये काही स्टीम करत नाही. मोस्ट इन थर्मल पॉवर प्लांट और स्टीम पॉवर प्लांट तिथं स्टीम जनरेशन होतं. किंवा आपले जे शुगर प्लांट्स आहे त्यामध्ये देखील बॉयलर असतो. बॉयलर मध्ये जे एक्सेसिव्ह एनर्जी आहे ते काय करतात, त्याचा स्टीम साठी वापर करतात. देन दे युटिलाइज दिस स्टीम फॉर पॉवर जनरेशन. नेक्स्ट पॉइंट हियर इट इज कोजनरेशन. ओके, now many industries require energy input in the form of heat called process heat. Process heat in this industry is usually supplied by steam at 5 to 7 atmospheric pressure and 150 to 200 degrees Celsius. Energy is usually transferred to the steam by burning coal, oil, natural gas and other fuel in the furnace. म्हणजे other than generation तुमचा other काय पर्पज असेल, प्रोसेस इंडस्ट्री जसे फूड प्रोसेसिंग इंडस्ट्री आहे, जर तुम्हाला समजा चिप्स तयार करायचे, त्या ड्रायिंग करण्यासाठी तुम्हाला स्टीमची गरज आहे किंवा हीटिंग करण्यासाठी तुम्हाला स्टीमची गरज आहे, त्या केस मध्ये तुम्ही वापरू शकता. So industries that use large amounts of process heat also consume a large amount of electric power. So instead of using electric power, you can just extract the steam from boiler and you can use it for process heating. So it makes sense to use already existing work potential to produce power instead of letting it go to the waste. So here is the schematic diagram. Here is a boiler and the whatever steam coming out from boiler, either you can, some part of it you can utilize for power generation and some part of steam you can extract and use for process, whatever processes are there in that industry. So this results in a plant that produces electricity while meeting the process heat requirements of certain industrial processes like cogeneration plant. So cogeneration is a method, in this case production of more than one useful form of energy such as process heat and electric power from सेम एनर्जी सोर्स. सेम एनर्जी सोर्स म्हणजे तुमचं बॉयलर, बॉयलर मध्ये थोडी स्टीम तुम्ही इलेक्ट्रिक जनरेशन साठी वापरा, थोडी स्टीम तुम्ही प्रोसेस हिटिंग साठी वापरा. प्रोसेस हिटिंग काय पण असू शकते डिपेंडिंग ऑन ऍप्लिकेशन. जसे की टेक्सटाईल इंडस्ट्री आहे, टेक्सटाईल इंडस्ट्री मध्ये असं धाग्याची काढण्याची प्रोसेस आहे, त्यामध्ये देखील कधी कधी ते स्टीमचा वापर करतात. किंवा तुमची फूड प्रोसेसिंग इंडस्ट्री आहे, तुम्हाला ते फूड्स ड्राय करायचे, जसं की त्याचं मॉइश्चर काढायचं आहे, त्यामध्ये हीटिंग करून त्या केस मध्ये देखील तुम्ही हे वापरू शकता. It depends on application. So this is another schematic for that. You can see here boiler कडून जी येणारी स्टीम आहे ती मध्ये एकदा त्यांनी एक्सट्रॅक्ट केलेली आहे या लेवलला. बरं, टर्बाइन मधून देखील त्यांनी थोडीफार हीट एक्सट्रॅक्ट केली आहे फॉर प्रोसेस हिटिंग. अगेन आफ्टर प्रोसेसिंग whatever remaining water, condensed water, that can be supplied to pump number 2, then it can be pumped to boiler pressure. Okay, so previous diagram was like only just we are directly taking heat from boiler. In this case, as you can see, some amount of heat is passed to steam is passed to process heater, then after some expansion in turbine again some steam is supplied to process heater. So that way also you can go for it. Okay, any doubt? Just like other than electricity generation, if you have another application, that way it is called as process heating or cogeneration. And the last point of this chapter is combined gas power cycle. Okay, so whatever we learned in this chapter was related to Rankine cycle. Rankine cycle is for only steam. Okay, then there are other power cycles which are called as gas power cycle. That in that case only air is used as working medium. Okay, whatever you see in jet engine, jet engine असतात त्यामध्ये काय केलं जातं, पहिल्यांदा ऍटमॉस्फेरिक एअर बाहेरून घेतली जाते, कॉम्प्रेस केली जाते, कॉम्प्रेस केलेली एअर कंबशन चेंबर मध्ये पाठवतात, तिथं फ्युएलचं बर्निंग होतं, बर्निंग मग झाल्यानंतर त्याची जी एनर्जी आहे त्यातून काय होतं, टर्बाइन्स रोटेट होतात, कंबशन इंजिनचे, जेट इंजिनचे टर्बाइन्स रोटेट झाले की त्याच्या बाहेर परत एक्झॉस्ट एअर पडते. So you take a time or we'll see an animation for that also working of jet engine. In that case, it works, it comes under gas power cycle. Okay, it comes under gas power cycle. So I'll show you. So this is a gas power cycle. In that case, first see gas power. What is the gas power cycle? So it works on the principle of Breton cycle. Outside air we take inside, it is compressed first to high pressure. This high pressure air, it is supplied to combustion chamber where fuel is supplied, ignition or the combustion takes place. In this case, lot of energy liberated. We utilize this high temperature, high pressure air to drive the blades of turbine, to drive the shaft of turbine, and this way power is produced. This shaft is coupled with generator and we can produce the electricity, or this will be coupled to propeller in the case of jet engines, jet aircrafts. Okay, now they have combined the power gas power cycle with the Rankine cycle. So whatever air is coming out from that, it is passed through a heat exchanger, and here whatever role of boiler, that is played by this heat exchanger. So we have hot gases coming out from the gas turbine, we have feed water pump which is coming from this side, heat exchange takes place and this water is converted into steam. So this steam is again passed to steam turbine, again the same process takes place, steam is taken out, it is passed to condenser, it is condensated to water, water is again pumped with the help of feed water pump. So this way combined effect is achieved. We can produce electricity first by gas power cycle, and in second phase we can produce electricity by use of steam. Okay, then there is this combined gas power cycle is given. So draw this diagram. Draw both diagram and give the title combined gas power cycle. Combined gas power cycle. Draw both the diagrams. So there is a MCQ always asked that the gas power cycle works on which principle or which cycle. So the cycle is Breton cycle, Brayton, and this power plant cycle, that is Rankine cycle. increase your speed. ते स्टुडंट कुठे गेले? खरे खरे एकदम फास्ट मध्ये काढतात मोठी within a fraction of seconds. Boys completed? So as you move up from second year to third year to final year, you will observe that your subjects will get simplified. Most of the difficult subjects are there in your second year of engineering. As you go up, your subjects will get simplified. For a simple subject comparative to this. And there is only one subject in last year, that is refrigeration, air conditioning. Again, that is very big subject. Otherwise, all the major subjects are being covered in second year of mechanical engineering. So like yesterday I got idea about another like project can be done in this case. Like you can do a program, you can write a program, either you can write in C or Python. In that case, the input you can take the boiler pressure and condenser pressure and the condition of steam. Only 3 inputs you will take, and directly your program will give you efficiency. So for that, lot of coding, I don't think much is required. Simpler, like 10 to 12 line of code will be sufficient. But you have to give input of this steam table. Okay. So at end of semester or throughout the semester, you can go for it. Learn the basics and create a program such that only that program will ask what is the boiler pressure, what is the turbine, condenser pressure, and condition of steam at turbine input. If you give sufficient only these 3 inputs, then it should give you the cycle efficiency, it should give you specific steam consumption, it should give you work ratio, all these parameters. Just giving only 3 inputs. ज्या numericals solve करायला आपण 20 मिनिटं लावली, that will come within a fraction of second. So you can check for that also. If you get completed, then okay, no problem. कळलं का तुम्हाला काय ऑब्जेक्टिव्ह? फक्त बॉयलरचं प्रेशर इनपुट असणार, कंडेन्सरचं प्रेशर इनपुट असणार, आणि कंडिशन ऑफ स्टीम ऍट दिस पॉइंट नंबर 3. म्हणजे इथं काय स्टीमची कंडिशन काय आहे, ट्राय सॅच्युरेटेड आहे का सुपरहिटेड आहे का वेट आहे, हे 3च इनपुट आपल्याला द्यायचे. मग डायरेक्टली ते तुम्हाला आउटपुट देईल की सायकलची एफिशियन्सी किती आहे, वर्क रेशो किती आहे, स्पेसिफिक स्टीम कन्झम्पशन किती आहे. असं एक तुम्ही छानसा कोड सी मध्ये लिहा किंवा पायथॉन मध्ये लिहा, कशात पण लिहू शकता. ठीक आहे. So completed. So combined gas power cycle, we'll read the theory and then we'll continue. The popular continued quest for higher thermal efficiencies has resulted rather than innovative modification to conventional power plants. The popular modification involves gas power cycle topping a vapor power cycle, which is called as combined gas power cycle or just combined cycle. The combined cycle of greatest interest is the gas turbine, that is works on Brayton cycle, and cycle topping with steam turbine, that is Rankine cycle, which has higher thermal efficiency than either of cycles executed individually. मग तुम्ही इंडिव्हिज्युअली गॅस टर्बाइन सायकल केली, गॅस पॉवर सायकल केली, किंवा इंडिव्हिज्युअली नुसती स्टीम सायकल केली, त्यात जेवढी इफिशियन्सी येते त्यापेक्षा कितीतरी पटीने जास्त त्यावेळेस तुम्ही कंबाईनला जाता त्यावेळेस इफिशियन्सी मिळते. ठीक आहे. So thermal efficiencies over 50% are being reported for this combined gas power cycle. So this PPT I will upload in the study material. You can refer it later. So now in the summary. So in the summary, we started with the Carnot vapor cycle. That is the cycle which gives you maximum efficiency. Then we move towards the practical cycle. That is Rankine cycle. We saw the deviation in the actual Rankine cycle. Then we saw what are the methods to improve the efficiency of Rankine cycle. So either you can lower the condenser pressure, or you can superheat the steam, or you can increase the boiler pressure. But increasing boiler pressure has a drawback that it reduces the net work done, and this drawback can be eliminated by reheating the steam. So for that, next we have reheat cycle, and then we have regenerative cycle. In regenerative, there are two types: open feed water heaters and closed feed water heaters. Then we didn't see this second law, it is not in your syllabus. And then today we covered cogeneration and combined gas power cycles. Okay, any doubt up to this point? Any doubt? What is the time? So I will open the quiz also. Let us check the quiz. So I think we have taken this quiz, vapor power cycle. So let us take one by one. What should be the critical temperature of working fluid for maximum efficiency of vapor cycle? So first one is working fluid should have critical temperature as low as possible. The working fluid should have critical temperature as high as possible. Critical temperature does not have effect on efficiency of vapor power cycle. So this is not true. It should be as high as possible. So there are boilers which work on critical pressure. The critical pressure of water is 22.6 megapascal. So there are supercritical boilers which work about 25 megapascal. Then there are ultra supercritical boilers and advanced ultra supercritical boilers which work up to 30 megapascal. So as you increase the pressure, the efficiency will increase. What is the drawback of steam as a working substance in power cycle? In a vapor power cycle, maximum temperature can be attained is limited. Okay, it allows smaller amount of heat addition at highest temperatures. It requires reheat, and reheated tubes are costly. So all of these are correct. काहीतरी limitations आहेत temperature चे, heat addition चे आणि reheating चे tubes आहेत त्या costly आहेत. So it is all of the above. The below diagram is the TS diagram of Rankine cycle with reheat. Which process represents the reheat? So you can check here. Should I modify it? So 1 to 2 is what? Sorry, 4 to 1 is what? What is 4 to 1 process? अरे chapter संपला सांगा. Huh? What is 4 to 1? Feed water pumping. Huh? एक मिनट म्यूट करतो.
visit will be there. And total 3 laboratories we have planned. So first one, advanced
What is 4 to 1? Feed water pumping. Specific words use. Feed water pumping. 1 to 2 is what? What? Heat addition. Constant pressure heat addition in boiler. Specific word. Constant pressure heat addition in boiler. What is 2 to 2 dash? It is a high pressure expansion. High pressure turbine expansion. पहिल्यांदा high pressure turbine मध्ये expansion होणार. What is 2 dash to 2 double dash? That is reheating. Again, you will take the steam coming out from high pressure turbine. Then you will supply it to boiler. It will be reheated to 2 dash. What is 2 dash to 3? Low pressure turbine expansion. So there are 2 turbines, high pressure and low pressure turbine. Then 3 to 4 is again condenser. So here correct answer is 2 dash to 2 double dash. Next, how are the effects of reheat and effect of regeneration on the efficiency of steam power plant compared? So effect of reheat is greater than effect of regeneration of plant efficiency. Effect of regeneration is greater than effect of reheat. Both have the same effect or cannot say. So correct answer is regeneration has more effect compared to reheat. Which among the following has the lowest efficiency than the others when they are operated in the same pressures? Ideal Rankine, ideal regenerative, Carnot cycle, or all of the same have same efficiency. See, first of all, Carnot will have highest efficiency. Then, if you are using ideal regenerative reheat cycle, in that case, efficiency will be more. So, what is the basic Rankine cycle? Ideal Rankine cycle that will have lowest efficiency. The mean temperature of heat addition of the Rankine cycle can be increased by reheating the steam, correct, increasing the superheat, correct, increasing the pressure ratio between which the cycle works. Increase the pressure ratio means you are increasing the boiler pressure or you are reducing the condenser pressure. The reheat cycle allows steam power plant to use higher pressure ratio to maintain required quantity of steam at the exit of turbine, that means dryness fraction, to increase the turbine work. So all of these are correct. What is the effect of superheated steam on efficiency of Rankine cycle? So in this case, efficiency of Rankine cycle decreases with increasing superheat of the steam. Efficiency of the Rankine cycle increases with increasing superheat of the steam. This is the superheat model. We have seen that PDF. In that case, the net work increases and the efficiency increases. Okay, so how many questions are there? There are many questions, I think. So have you attempted all? So you can attempt as many times as you want. I will again increase the timing of that. It is, I think, expired. So I will increase the deadline of that. So you can practice later. So I will update that in the study material sheet also. You can check that. So please enter your attendance in the chat box and then we'll stop. So enter your attendance in the chat box, then we'll stop. Roll number 2. 28. Today date is 3. So with this we stop. In next lecture we'll start the new chapter of section number 2. Thank you.